Tesla Bot Optimus, an ambitious product with the potential to be a financial game-changer for both Tesla and the entire market, is continuously touted by Elon Musk, who confidently claims it will be available for sale by the end of 2025 and speaks optimistically about mass-producing 5 robot legions. However, harsh reality seems likely to limit this goal. When will Tesla actually be able to begin mass production of the Tesla Bot? In today's episode, we will reveal 3 major reasons why Tesla is being forced to delay mass production, and the truth behind the scenes. And welcome to Techno Creators. Before we begin, please help us reach 5,000 subscribers. It will be a huge motivation for us to continue bringing you great tech episodes. The new hardware cannot produce for mass production. Although Tesla's greatest strength lies in hiring the smartest engineers in the world and motivating them to work at an incredible pace. If we go back to 2016, Tesla published a blog post stating that all of its electric vehicles were equipped with the necessary hardware to achieve full self-driving. This meant that owners of those Teslas could expect autonomous trips and eventually even send their cars out as robo-taxis to earn money when not in use. Later, Tesla quietly deleted that post, and now we can see why. Since then, Tesla has shipped millions of updated hardware, 3 computers to replace older hardware 2.5 systems, as they were not capable of achieving FSD. Now Musk says even those newer chips will also need to be replaced. Meanwhile, the newer hardware 4 computers have been experiencing some short-circuit issues, which have led to large-scale recalls in both the United States and China due to related symptoms such as malfunctioning rear-view cameras. Currently, the company is developing hardware 5 for the Optimus robot. Although Tesla's 50,000 GPU training cluster at Giga Texas, named Cortex, has enabled a breakthrough in the computing hardware equipped on Optimus, with major improvements in safety and comfort thanks to 4.2 times more data, higher resolution video input, a 2 times reduction in photon-to-control latency, and a redesigned controller, among other enhancements. Mass producing this hardware for Tesla Optimus is no easy task. Tesla still has many ambitious plans for its electric vehicles, especially the upcoming Model 2, which will require a significant amount of hardware dedicated to self-driving capabilities. The new hardware developed by Tesla specifically for Optimus is expected to be manufactured using a 7-nanometer process and will serve multiple functions, including autopilot and full self-driving. Additionally, Musk has stated that while Hardware 3 was revolutionary, Tesla has been working on a next-generation chip that will be approximately 3 times more powerful than Hardware 3. He later mentioned that this unreleased chip is expected to enter production in about 2 years. As a result, the mass production of the Optimus robot may be delayed until 2026, or even 2027. Globally, it's expected that at least 100,000 vehicles equipped with Hardware 3 and the FSD package will be on the roads, pushing Tesla's retrofit demand to over 500,000 cars. Musk was right when he said that replacing the computers in more than 500,000 Teslas would be painful. Not only would it put massive pressure on Tesla's service capabilities, but the cost could easily exceed $500 million. Before we move on to the next reason, make sure you've hit that subscribe button and turned on notifications by ringing that bell icon so you don't miss any future episodes. Production cost challenges. Recently, inflation in the United States has continued to rise, significantly impacting the overall economy, and particularly the high-tech manufacturing sector. One clear example of this impact is Tesla's struggle to realize its goal of bringing the humanoid Optimus robot to market at a price of just $20,000, a figure once considered ambitious yet achievable. Like many other manufacturing companies, Tesla is grappling with rising costs of raw materials, from rare metals used in actuators and sensors to the growing expenses of shipping components from suppliers around the world. Although the company has heavily invested in localizing production and automating its manufacturing lines, macroeconomic factors like inflation remain formidable obstacles. Tesla Optimus humanoid robot is expected to be a groundbreaking advancement in robotics and automation. Elon Musk has repeatedly stated that Tesla's goal is to produce Optimus at a cost of just $20,000, a price point that could make the robot widely accessible in everyday life, from manufacturing and logistics to personal care. However, in the current inflationary environment, that price target is becoming more difficult than ever to achieve. The costs of electronic components, AI processors, high-density batteries, and servo motors, all essential parts for operating a humanoid robot, have risen significantly. Additionally, labor costs in the U.S. are also climbing to keep up with the rising cost of living, further driving up domestic manufacturing expenses. Tesla has been expanding its manufacturing facilities in the U.S., such as Giga Texas and Giga Nevada. These factories are not only producing electric vehicles, but are also expected to serve as future centers for the development and assembly of the Optimus robot. By establishing its entire production line in the U.S., Tesla can take advantage of tax incentives and support from the U.S. government for advanced technology companies. Although labor costs in the U.S. are significantly higher than in other countries, Tesla compensates for this by increasing the level of automation in production, using Tesla bots themselves to build an efficient Optimus production line with less reliance on manual labor. Furthermore, signals suggest that both the market and the tax policies set by the government appear to be recovering from previous tensions, making it likely that mass production of the Tesla bot could begin as early as the beginning of 2026. Short of autonomous. The final and most important reason that Optimus may be able to determine a specific timeline for mass production is that it seems to be at a standstill. Or in other words, the robot's autonomy in its environment has not yet reached the expected level. Over the past few months, Tesla has focused on improving the robot's gait, making it more agile, powerful, and confident in its movement. The robot's movement speed suggests it may be able to reach 3 miles per hour. Elon Musk's latest event seemed to promise a bold future, unveiling Tesla's ambitious cybercab and the humanoid Optimus robot at the We Robot launch. At the event, we witnessed Optimus robots showcasing impressive interactions, engaging with guests by socializing, serving drinks, and even playing games like rock, paper, scissors. Just 2 years ago, these robots were like shy wallflowers, unable to take the stage without assistance. The evolution has been remarkable. On stage, Musk confidently declared that this would be Tesla's biggest product yet, sparking excitement not just for the robot itself, but across Tesla's entire portfolio. However, one of the Optimus robots candidly admitted on camera that it was being assisted by humans and was not yet fully autonomous. This revelation didn't come as a surprise to those familiar with the underlying concerns surrounding the event. There were echoes of previous controversies, especially when Musk had earlier highlighted the robot's progress by showcasing its ability to fold clothes. Observers quickly noticed the obvious presence of human hands in action, undermining claims of true autonomy in the robot's capabilities. Although in the latest update video, Tesla Optimus shows significantly improved mobility, no one yet knows exactly how autonomous the robot is in a factory environment or in daily life. It may have achieved over 50% work efficiency, but the rest remains a mystery.
In 10 years, probably 90% of miles driven will be autonomous.
Huh.
Wow.
That fast.
According to an internal report leaked at the end of 2024, the actual efficiency of Optimus on the factory line currently reaches only about 40 to 50% compared to a human worker, while the accuracy of its operations when tested is only around 70 to 75% in a standardized environment. When deployed in uncontrolled settings such as homes, offices, or construction sites, this efficiency drops below 30%. Although AI is advancing rapidly for a humanoid robot like Optimus to achieve true autonomy, it needs not only flexible mobility, but also contextual understanding, natural language processing, dynamic environment management, and continuous learning from real-world data, capabilities that still face many limitations today. In summary, Optimus has tremendous potential, but achieving full autonomy in real-world environments remains a technical challenge that could take many more years to overcome. Much like Tesla's FSD system, the promise of 90% autonomy for humanoid robots may take a decade to materialize, if not longer. We've long known that Tesla has been using a customized FSD build to allow newly manufactured vehicles at Giga Texas and Fremont to autonomously move from the production line to the delivery lot. Although we know they are using a customized build of what might be FSD unsupervised, Tesla has also confirmed that they have accumulated over 50,000 driverless miles in total from autonomous vehicles moving to delivery lots. This could be the first time a purely general-purpose AI solution for autonomy is being realized. Tesla and several executives continue to share more content about autonomy and the Tesla Optimus network. The same level of autonomy will be required for Tesla Optimus to participate in mass production, the ability to move independently to the staging area after completing the assembly and inspection process, all without intervention from remote operators. How was Tesla Optimus tested at the Giga Nevada factory? Surprisingly, in an interview, a former Tesla engineer revealed that the Tesla Bot Optimus Gen 3 is performing tasks daily inside the Nevada factory, which is known for its large-scale 4680 cell battery production process used for the Cybertruck, Cybercab, and Tesla Bot. Optimus seems to be a good fit for this space, with a task in the factory that needs to be automated, but would take a long time to accomplish in the old way with robots and automation. This is especially true if Tesla has tasks that are always changing, where nothing ever stays stable. Humans spend time setting up equipment and programming everything to do something that may only last a few months before the equipment changes. Then, people need to go back and redo everything, creating a lot of technical overhead costs. You need to pay many engineers to do a lot of work. If you have a product like Optimus that is more flexible, you can assign a task, teach the task, and have employees teach the robot what they want it to do, as opposed to having an entire team of engineers program devices that allow you to set up and create tasks that can be automated. But this would be too much work for the amount of time the task would take, allowing you to use Optimus to automate those tasks and actually get a return on the time you would spend automating it.
Optimus is already performing tasks in our factory, and we expect to have Optimus production version 1 in limited production starting early next year.
In addition, Elon Musk has emphasized that the Tesla bot is performing tasks inside the factory. Although there has been no official statement regarding the specific tasks Optimus is carrying out, previous video footage suggests that Optimus may be performing tasks such as removing batteries from the production line and organizing them into trays. Sometimes the methods of operation need to be adjusted, but everything seems to be handled efficiently by Tesla's team.
But I think we'll literally build a legion, at least one legion of robots this year, and then probably 10 legions next year. And I don't know, it's kind of a cool unit, you know, units of legion. So probably 50,000-ish next year.
Elon Musk has unveiled an ambitious plan during Tesla's Q1 2025. Tesla aims to produce its first legion of humanoid robots by the end of this year. This isn't just a major technological breakthrough. With Musk targeting the production of 5,000 Tesla bots in 2025, these robots won't just serve in Tesla's factories, they could also assist with daily tasks at home, in hospitals, and even in emergency situations. These robots are not just machines. They're envisioned as companions, helping hands in every aspect of life, proving they're far more than simple automation. Tesla Bot is barely 4 years old, and its journey has been nothing short of extraordinary. What started as a person in a robot suit has now evolved into a fully functional machine, equipped with flexible movements and advanced algorithms that allow it to think, adapt, and assist. From supporting people in daily life to providing care for the elderly and disabled, Tesla Optimus is being recognized not just as a robot, but as a future caregiver, perhaps even the one helping take care of your better half in old age. We often compare Optimus to humans, a rather tough standard, considering that at the end of the day it's still just a machine. It hasn't yet surpassed the agility or responsiveness of a human being. But thanks to artificial intelligence, its ability to process and think has already reached levels beyond ours, while still remaining under our control. When we look at the big picture, Boston Dynamics has spent over 3 decades developing robots, yet their creations still mainly focus on running, jumping, and acrobatics. Similarly, some humanoid robots from China share the same traits. They can perform flips and run smoothly without stumbling. But what sets Tesla's robot apart is its ability to perceive the world more realistically, using a system of 8 sensor cameras without relying on radar, LiDAR, or any other scanning technology. What is even more fascinating is the way Tesla is testing Optimus. What are these breakthrough technologies that are about to be unveiled? If we've ever discussed why Tesla chose not to use LiDAR in combination with a camera system for Tesla Optimus, some believe the decision stems from LiDAR's relatively large size and increasingly high costs. However, the tech world never stands still, and some suppliers now have the capability to produce an entirely new kind of LiDAR device, weighing and measuring as little as 7 millimeters. These compact sensors, developed by RoboSense, can be integrated into robots and manufactured at a cost of just $499. Back to Tesla Optimus, as shown in the recent video navigating rough terrain, the robot demonstrates impressive flexibility and balance control, even when going uphill or downhill. What's most fascinating is that Milan Kovac, Vice President of Engineering for Optimus, explained exactly what it took to get Optimus to this point. The robot is genuinely progressing in its ability to walk and can maintain balance on uneven ground, even while walking blind. Tesla has achieved this using only sensors, all powered by a neural network running on embedded computing hardware. And here's the key question: what kind of sensors did Tesla use that allowed the robot, without a traditional camera setup, to accomplish this? The answer could very well be LiDAR, one of the technologies Elon Musk himself once deemed unnecessary for Tesla products. Essentially, Tesla is building Optimus from the ground up, relying on as much supplemental data as possible during vision training. This is similar to how they train FSD on vehicles by using LiDAR rigs to validate the accuracy of their vision system. This approach proves that Tesla does in fact see value in compact LiDAR sensors for Tesla Optimus. The LiDAR sensor we are referring to is not a traditional rotating mechanical type. It is a fully solid-state LiDAR, equipped with an ultra-wide 120 by 90 degree field of view. It combines high performance, a compact design, and automotive-grade reliability. This enhances the robot's ability to detect object sizes, contours, and distances in real time, making it highly capable in tasks like obstacle avoidance, mapping, and navigation. This technology promises to provide comprehensive and precise environmental awareness, essential for advanced autonomous navigation and decision-making. With a maximum detection range of up to 75 meters, 7 times that of conventional depth cameras, it represents a significant leap in robotic perception. Building a realistic surrounding environment becomes more achievable with over 260,000 points per second and 144 neatly structured beams. This allows for precise detection of both static and dynamic small obstacles. It excels in efficient 3D mapping, accurately reconstructing environments such as roads, yards, homes, warehouses, and ports. To better illustrate the effectiveness of LiDAR technology, we would need a comparison test between Tesla's camera-only autonomous driving system and a LiDAR-based system, such as one powered by Luminar. The experiment would evaluate how vehicles react when encountering a child on the road under 6 different scenarios: standing still, suddenly running onto the street, in fog, in rain, under bright light, and standing behind a wall. Test results showed that LiDAR generally performed better, mainly due to its superior performance in foggy and rainy conditions. There are also some notable drawbacks to vision-only technology. For example, it can struggle when facing bright lights, and Tesla has previously encountered issues with vehicles failing to detect trucks crossing the road, leading to accidents, or confusing overpasses with signs or the sky. Both of these problems can be addressed by cross-referencing data from multiple sensor types. Relying solely on vision would limit Optimus's working environment and prevent it from performing tasks in conditions involving fog, mud, or dust. What significant update on Tesla Optimus's vision? All right, it seems that everyone knows Tesla Optimus is equipped with a set of 8 sensor cameras, but perhaps you've overlooked how these camera systems actually work. Remember, Optimus runs on the same overall AI stack as FSD. In fact, Optimus uses the FSD computer and a branch of the FSD stack for vision-based tasks. The camera array builds a 3D model of the environment with accuracy nearly equivalent to the human eye. Then, the hardware component processes the images captured by the cameras in real time, with a latency of just 0.2 seconds. That represents a significant leap forward in technology. According to our research, a new 4-camera cluster technology has been developed, integrating multiple sensors to provide a hardware-level fusion of depth information, image data, and motion posture data, all synchronized in both time and space. This enables the robot to capture comprehensive details about its environment, overcome interference from sunlight and highly reflective surfaces, and adapt to a wide range of indoor and outdoor scenarios. With a maximum range of up to 70 meters, 6 times greater than that of conventional 3D cameras, this distance is well suited for a robot designed for indoor tasks, like Tesla Optimus. It breaks the limitations of traditional cameras, delivering superior performance to fully meet the demands of intelligent robots in obstacle avoidance both indoors and outdoors, as well as in mapping and hand-eye coordination. This significantly enhances both efficiency and safety. Tesla has shown what the robot sees, and it looks very familiar. That's because the neural networks are being pulled directly from autopilot. However, training data must be collected specifically to represent indoor environments and other objects not typically encountered in vehicles. Engineers have trained the neural networks to identify high-frequency features and key points in the robot's camera feed, such as the charging station. Tesla has also utilized the autopilot simulator, but adapted it for use with the robot programming system. Optimus's torso houses a centralized computer, which Tesla says is designed to handle everything the human brain does, such as processing visual data, making split-second decisions based on multisensory input, and facilitating communication. In addition, the robot is equipped with wireless connectivity and audio support. The reliance on AI and machine learning algorithms enables Optimus to master the automation of a wide range of tasks. This is because it can adapt based on the context of its environment. In addition, Optimus is equipped with an intuitive navigation system powered by an end-to-end neural network for movement. It has been trained on a library of natural motion references, such as taking a box off a shelf, lifting an object and placing it on a surface, taking medicine out of a container, watering plants, and pouring water. Optimus's fully trained neural network has also been shown to autonomously classify objects by color, continuously learning in the process. Tesla Optimus is often compared to Boston Dynamics' Atlas. While Optimus is designed using aluminum and plastic, Atlas incorporates steel, aluminum, and 3D printed components. It is heavier by comparison and built to operate in more challenging environments, such as construction sites and in search and rescue missions. However, more humanoid robotics technologies are now entering the market, including Figure AI, Unitree, and several other models emerging from the Chinese market, all of which are beginning to draw comparisons with Optimus. And when can you buy a Tesla Optimus? With the disclosed production cost of $15,000 per Tesla Optimus unit, Tesla may go beyond its initial plans, such as offering rentals at $40 per day or selling them at a higher price to optimize profits, potentially not at the previously stated $20,000. However, shortly after things run smoothly, that is, once Tesla can mass-produce the robots, they will focus on bringing this first lineup into production. It could turn into an assembly line. If they manage to produce between 5,000 to 10,000 bots in 2025, that would be their current target, ramping up the supply chain. Once they exit the manual production phase and shift into assembly line manufacturing with mass production, building dozens per day, the selling price of Tesla Optimus is expected to gradually drop, possibly even below $20,000. Why can they do this? Tesla may produce hundreds or thousands of units, but that represents a different mode for the company. They are leading the way and are currently the best at operating car factories. But then Starlink is able to produce mini Starlink terminals in their own factory. And if SpaceX can manufacture 5.4 million Starlink terminals per year, then Tesla will be able to produce 1 million Optimus units annually. This is incredible, because it's more than just that. They're similar, as if they're very closely related. And if Tesla can produce 500,000 cars per year, then why wouldn't they be able to produce 5 to 10 million Optimus units at a dedicated robot factory? They can, and they will.
So this year, we hopefully will be able to make about 5,000 Optimus robots. We're aiming for enough parts to make 10,000, maybe 12,000. But since it's a totally new product with totally new, like everything is totally new, I'll say like we're succeeding if we get to half of the 10th.
In a recent live stream, Elon Musk made some bold statements and shared a few ambitious predictions for his humanoid robot project. Now, we're not saying everything he says will happen 100%, because, well, it's Elon. But some things are definitely being set in motion. Tesla plans to produce at least 5,000 Optimus robots this year, although in true Elon fashion, he casually mentioned that the number could reach up to 12,000. So things are about to get interesting. The humanoid robot race is heating up, and after closely following Tesla Optimus and the company's progress for some time, it's clear that Tesla holds a significant cost advantage over its competitors. Elon Musk even claimed that Tesla could produce Optimus for just $10,000, which is insane. On the other hand, Figure AI is also one of the more reliable companies with a clear product development strategy. Their robots are being developed for use in factories and to perform tasks in place of humans, similar to Tesla Optimus. Back to Optimus production. As we mentioned earlier, Tesla isn't just building a product, they're pioneering an entirely new industry. This isn't like manufacturing a new phone or car. We're talking about a humanoid robot that requires absolute precision in every component, algorithm, and movement. Unlike with cars, everything from the assembly line to the AI software is being built from scratch, not copied from other existing prototypes on the market. If you've seen one of Elon's posts on X, you might remember that he confirmed Tesla will offer Optimus both for rent and for direct purchase. But rental will be the top priority. Why does he prioritize this? Instead of a one-time sale, leasing generates a steady and recurring income stream, monthly, quarterly, or annually. This allows Tesla to better predict cash flow and plan long-term finances. Many customers may not want, or be able, to pay a large upfront sum to own a brand new product. Offering rentals at a lower cost makes the product more accessible and expands the potential customer base. In a market where consumers increasingly prefer the use-it-don't-own-it model, like cars, machinery, and tech equipment, leasing becomes a key competitive advantage to avoid falling behind. That said, if you're someone who wants to personally own a Tesla bot, it likely won't be difficult, especially with a price under 20 grand. What makes the Tesla Optimus so different? While most robotics companies focus on building a smarter AI brain or optimizing the walking speed of their robots, they often overlook one crucial aspect: the hands. Human intelligence isn't just about thinking, it's about doing. And what is our most powerful tool for shaping the world? Our hands. Every structure, every technology, every complex mechanism we use daily exists thanks to the dexterity and precision of human hands. Tesla understands this. That's why Optimus is designed not only to be intelligent, but also highly capable. Optimus could be the first robot to truly function like a human, bridging the gap between AI and real-world usefulness. This could be the game-changing advantage that sets Tesla's humanoid robot apart from the rest and brings us closer than ever to the future. Additionally, Musk stated that Optimus will be produced in limited quantities in 2025, with plans to deploy over 1,000 units within Tesla's own facilities, and the potential for production for other companies starting in 2026. Optimus is being trained by the supercomputer Cortex, an AI training supercluster currently being set up on the Tesla headquarters campus in Austin, Texas, to enable what they call real-world AI. What do you think about this? Feel free to share your thoughts in the comments section below. We hope to bring the best information to you. Please give a thumbs up if you like this. Join Techno Creator by subscribing and hit the bell icon so you will not miss out on any awesome videos. We value your feedback. Thanks for watching. Until then,